Good afternoon, everybody, and welcome to the concurrent session. For those of you that don't know me, my name is Sean Hammond. I'm the ADM of Safety, Policy, and Engineering with Alberta Transportation. I also happen to be, unfortunately, Alberta's rep on the CCMTA Board of Directors. Unfortunately for you, I'm going to be the moderator of this session, right? So the following presentation will last about an hour, and we'll conclude with a question and answer period with our guest speakers. So what I'd like you to do, and I don't know what your preference is, hold your questions till the end, and we'll see where we go. So this presentation is Electronic Logging Devices, Reliability and Efficiency for Hours of Service Enforcement. And here today we have Alex Capelle, Program Manager with Continental Corporation's Commercial Vehicles and Aftermarket Business Unit. This goes on for a while, so you can be embarrassed, you can be suitably embarrassed, but it does go on for a while. So, and this is my only time to shine because I got voted out at the island the other day. So, all right, Alex is currently responsible for leading the company's tachograph and telematics activities in North America. He has more than 15 years experience in the automotive industry with an expertise focused on telematics and electronic logging devices, tachographs in Europe, Asia, and North America. Prior to Continental's acquisition of Siemens VDO, Alex held roles as Senior Product Manager and Project Manager for Vehicle Data Recorders of Siemens in China. He also managed EOBR programs in Asia, South and North America, and to help identify EOBR legislation requirements in Europe. Now Andy's back. Sorry guys, I have to start again, all right? Alex is Secretary of the TMC EOBR Task Force, a member of the American Trucking Association, the Commercial Vehicle Safety Alliance, the Canadian Trucking Alliance, and of course CCMTA. So without further ado, Alex, the floor is yours. Actually, the microphone is yours.
So good afternoon. Thank you for joining, and I will try to keep you awake through this long hour. So a quick word on Continental. Continental is a very large corporation composed of 5 divisions. The chassis and safety, so the automotive division, chassis and safety, powertrain and interior, that do electronics for cars as well as commercial vehicles, all kind of vehicles actually, and then the rubber and tire divisions. So just a very short word to introduce Continental, because usually the public knows the tires, but not necessarily the fact that we are also one of the largest suppliers for electronics, automotive electronics. And all our products are geared towards 4 goals, which are improving safe mobility, allowing a safe power to reduce emissions, and improving intelligent driving through connectivity, as well and we're doing all that at the best cost possible. So now to the subject of ELDs. I'd like to start first with a few definitions. What are analog tachographs? So analog tachographs have been used in many countries in Europe for over 35 years. They record data on diagram charts, and in Europe especially, they are now replaced by regulations. All new installations are done with digital tachographs. So you can still find analog tachographs in Europe for older vehicles that were put on the road before 2006. Digital tachographs, they have been compulsory in the European Union since 2006. In neighboring countries, AETR countries, so those are countries that have an agreement with Europe on road transport, with the European Union. So those, the AETR countries also mandate the use of digital tachographs since 2010. And a general characteristics about digital tachographs, they use chip cards for driver identification, as well as to transfer the data from one vehicle to the other, and also back to the office. And they also have a standard interface to allow the download of the electronic data. Moving on with definitions. In North America, in the US, the AOBRDs, automatic onboard recording devices, are devices that comply with the US regulation 49 CFR 395.15. And this regulation was published in 1988. Those devices have to be integrally synchronized with the vehicle, so linked to the vehicle. And there is not many technical requirements around AOBRDs otherwise. EDRs, that's the Canadian version of AOBRD. They comply with Section 83 of the Canadian Commercial Vehicle Driver Out of Service Regulations. So both today on the roads in North America, US and Canada, then both AOBRDs and EDRs are in use or can be used by fleets and drivers instead of using paper logs. So those systems record the driver's status. They allow to either display the logs or print them out, and they must be connected to the vehicle in some form. It can be either wired or wireless, for example, through Bluetooth. But what is important is that there has to be a connection to the vehicle. A system that's such like an app running on a smartphone without any link to the vehicle cannot be compliant with today's AOBRD or EDR requirements in the US and Canada. That functionality can also be part of a fleet management systems that then offer a lot more features than just recording the logs. So fleet management systems are also called onboard computers. They record lots of information about the vehicle, the location of the vehicle, tracking where it has been, also freight-rated data. It will typically also allow to transmit information in real time through cellular communication or also sometimes satellite. And the fleet management systems per se do not need to comply with any specific regulation, although they may have an AOBRD ERD functionality, in which case the system must comply with the AOBRD ERD rule in the US and Canada. So more definitions. It's the EOBR, electronic onboard recorders. Those were systems that were defined in the FMCSA regulation 49 CFR 25.16 that was published in 2010 and then subsequently vacated in 2011. So strictly speaking, there is no EOBR in use today. All the systems in use today are either AOBRD or EDRs. And then the next step, ELD, electronic logging devices. This is the proposed rule that was published by FMCSA in March of 2014, and for which the final rule is expected in September of this year. In the equivalent for Canada is still called EOBR. Actually, there was a draft standard that was published in 2013, and there is no official date, to my knowledge, for a final standard and a date. So moving on with the countries that have adopted ELD or tachograph regulations, we can see that in many countries have been using ELDs, tachographs for many years. All 27 countries of the European Union are using a digital tachograph, and previously were using analog tachographs. Also, Brazil has been using tachographs for many years, and in Asia, Japan. many countries also have ELD tachograph regulations, but have them partly enforced, such as Russia or the 24 ATR countries, so countries neighboring Europe that have a transportation agreement. And also many countries also have regulations in preparation for tachographs and ELDs, among which in North America, the US and Canada. But from that chart overall, we can see that over 50 countries in the world actually have mandated tachographs and ELDs. So more specifically in Europe, over 5.5 million tachograph systems, whether analog or digital, are being used in trucks and buses to record the driving time and rest time of the truck drivers. The focus of the mandate in Europe is to ensure a good enforcement of the health service regulations and avoid fatigue drivers that may cause accidents. There is also a goal to level the playing field by ensuring that all fleets comply fully with the health service regulations. You can note also that in Europe, since there is also speed limiter regulations in place in all of Europe, the tachographs are also required to record the speed, but it's actually a secondary data set of the tachographs in Europe. It is not the primary one. The primary one is the health service of the drivers. In South America and Asia, there is, in most countries, actually no mandatory requirement to record the driving time and rest time of the drivers, because there is, in many cases, actually no health service regulations. So in many of those countries, the tachographs are actually used to record the speed and to enforce the either the speed limits or also for accident analysis when accident happens. So from this very short overview on the number of countries that have adopted and that have been mandating tachographs or ELDs, we can see that most of the developed countries in the world have regulations for driving time and rest time, and more than 50 countries have required to use electronic logging devices in trucks and buses. Out of those many experience, we can draw experiences. We can draw some conclusions of what has been leading to success or failures in all those countries. The goal for a tachograph is to increase road safety and also to allow the fleets and the drivers to handle easily the health service regulations on the day-to-day operations. The systems, and that is very important, have to be cost-effective, so that it is possible. It is for the fleets to implement it and well accepted by the transportation industry. The authorities and the law enforcement have to be able to trust the data coming from the systems. Without the trust in those data, then the systems will be simply useless. And the fair enforcement through the use of tachograph will also allow to have a level playing field between the fleets. another key factor another key goal for the tachographs and the ELDs is to offer the possibility of increasing productivity for the fleets by using the data coming from the ELDs, or to have an interface that allows to make a better use of an improved use of the ELDs. What are the challenges that have been met in implementing tachographs and ELDs? For the industry, from an industry point of view, one of the biggest challenges is the cost of the systems. Every dollar that is added to the vehicle or in a day-to-day operation counts, and clearly, when there is a mandate for a new system, the acceptance of the systems is only possible if the cost is minimal. The second challenge is for the operators, for the fleets, to be able to adapt their processes to have a strict compliance with the house service rules, because with paper logs, this strict compliance is not necessarily there. Because the enforcement cannot be very effective. Another challenge, the next challenge is how are the fleets going to choose the right ELD, and especially finding out which ELD is actually compliant. This is something that I will talk more about in the future slides. And then one of the last challenge is the data privacy. The fleets, the owner operators want to be sure that the data about the drivers, about where the vehicle has been, is kept private and cannot be accessed by anybody, as well as only the data that is needed for law enforcement to access to is available to law enforcement, and not other data that are private for the fleet. Challenges from the perspective of the enforcement. The first challenge is how to access the data at roadside, and that in all situations. So whether there is cellular connectivity or not, whether it rains, snow, or whatever the conditions, there must be an easy and simple way and quick for the enforcement to access the data. And also there must be it must be possible to see at roadside the data and be able to analyze it. The once the enforcement receives the data, then the key a key factor is to be able to trust that data. The enforcement will want to know if the data has been manipulated or if it's the original data that was actually recorded by the unit. And the enforcement also needs to know which devices can be trusted. That is not something that is obvious. If you look at the situation today, for example, in North America, there is no simple way for the enforcement to know which device complies with the AOBRD regulation or not, because there is no central repository that tells to the enforcement this ELD or this tachograph is compliant with the rules. And then the last challenge is the cost of implementation for the enforcement to be able to establish those systems. So key points for an ELD regulation to be successful. there needs to be, and this is not related then directly to ELD, but there needs to be a practical house service regulation. If the house service regulation does not work well, an ELD regulation will not fix that. That's so the acceptance of the house service regulation is needed. There has to be a standardization of interfaces and certification requirements. There needs to be a security concept that allows that any tampering of the system will be detected by the enforcement or also by the fleets. It could be tampering by the fleet, or it can be tampering by the drivers. So the security concept must allow both the fleets as well as the enforcement to detect if any data has been manipulated. The system must ensure that all the data is completely and accurately recorded. And it also must ensure that the data can be made available, and all the driver's activities are recorded accurately, and that the data can be made available easily to the enforcement. And that data has to be trustable by the enforcement and also trustable at courts if need be. Then the system must also, the ELDs must have access rights that allow only authorized users to access the data, so that only fleets and drivers that are owning or driving the vehicle can access the data, and that enforcement also can access the data, but not everybody can access all data. And then there needs to be adequate penalties for infractions, and those infractions are, as we know today, or would be as we know today, infractions of the house service rules, but also most importantly, infractions about tampering with the data recorded in ELDs. There also needs to be interfacing and expansion possibilities for ELDs so that they can allow the fleets, the carriers to improve productivity. So more on standardization. It is important to achieve a certain level of interoperability between the systems, so that when a driver changes from one vehicle or from one driver to the other, so that you can have a continuous recording of its activities. That's why it also, to facilitate the life of the drivers as well as for the enforcement, there needs to be a minimal user interface standard. For example, the way the data is provided to the enforcement at roadside has to come in a standardized format, just the way it is today with paper logs. There is a standard graph grid. There also needs to be a standard for that format to be for that data to be provided to enforcement. The driver identification needs to be unique and as much as possible actually unique across the board between different ELD systems. If not, then if it needs to be at least unique within one ELD system. The way to move the data from of a driver from one vehicle to the other, and also back to the office, needs to be as standardized as possible. And then most importantly, the interface and the data structure for the enforcement to download the data has to be standard, so that the enforcement can get the data properly. So security and data privacy. When it is very clear that if ELD systems are not, or EOBR or tachograph systems are not sufficiently tamper resistant that the data will be manipulated, and there will be a lot of attempts and lots of energy spent by carriers that are willing that want to cheat, they will spend lots of energy to try to manipulate logs if they can. So, and I'm not saying that all carriers try that, but the goal of implementing ELDs is actually to improve the health service enforcement. So therefore, the systems has to be sufficiently tamper resistant. And to that effect, in order to ensure a uniform level of tamper resistance between the different systems, there needs to be a definition of the tamper resistance level to be achieved by all ELD systems from all suppliers. Some form of data encryption will be needed to ensure that the data is protected when it is moved from one device to the office. This is for data privacy purposes, so that not anybody can access that data. And there will also be the need, once there is a tamper resistance level defined, there will be the need for a third-party and independent certification process for the ELDs, so that the carriers as well as the enforcement can know and trust which systems are actually compliant. So looking at the proposed rule in the US for electronic logging devices, the certification process that is proposed is a self-certification, more I would call that a strong self-certification. In the proposed rule, there was no test criteria proposed yet, but they are thought to come in the final rule. The vendors will have to register the systems with FMCSA, and FMCSA will maintain a list of the certified systems on a specific website. When it comes to tamper resistance, the ELDs will have to be connected to the data bus of the vehicle. For vehicles that are actually older, that do not have an ECM, then they can also get the information of the vehicle moving from sensors. The systems will have to record the miles, the engine hours, as well as power on and off. And that's, but there is no really specific definition of or scientific definition of the tamper resistance level that needs to be achieved by ELDs. So that is potentially a risk, because you can have, it'll be possible in the end to have systems that vary significantly in terms of tamper resistance, and with no real ability to determine for FMCSA which is actually sufficiently tamper resistant or not. When it comes to the data transfer to the office, the fleets, the drivers will have to send the data back within 8 days to the office, and that can be done either manually through a manual process using any kind of data transport medium. It can also be done wirelessly and real time. It doesn't have to be done real time though. And that is important that it doesn't have to be done real time, because for very small carriers, this is the real-time communication of ELD fleet management systems is actually the most costly part of the systems. So the real-time communication of the data is not needed to have a tamper-resistant system. So it is important that the rule allows for a system that the rule does not require wireless communication, because it will therefore allow very cost-effective systems on the market that are most attractive for small carriers. Looking at the data transfer interfaces that are required in the proposed rule, ELD proposed rule in the US, there are actually 7 options, so this is a bit complicated. There is multiple combinations possible, so it can be either printout or QR codes. It can be wireless web services and USB and QR codes, or wireless web services and USB and TransferJet, or Bluetooth and USB and QR codes, or Bluetooth and USB and TransferJet, or wireless email and USB and QR codes, or wireless email and USB and TransferJet. So lots of combinations. That is, from my point of view, complex, and that if that was actually to be implemented like that in a final rule, would lead to a high level of complexity, potentially for the ELDs, and also most importantly for enforcement. There has been lots of questions raised about the viability of the QR code and TransferJet, whether it will be actually allowed to reach the goals of transmitting the data at roadside. So it may well be that in the final rule then those 2 technologies are not required, which will actually simplify a lot that matrix and reduce the complexity and the cost of the systems. There is also no specific requirements about in how much time is allowed to provide the logs at roadside. Does it have to be within a minute, or can it be within 20 minutes? So that can be that's also a concern that would probably need to be fixed. Still, the proposed rule, ELD proposed rule, for roadside inspections, it requires to show the data for manual inspections. It requires to show the data either on a printout or on a display. So there is pros and cons for both. The advantage on the printout, it allows to keep the proof. It can be available outside of the cab, and it's very simple to use. The information provided on this printout is a standard, can be the standard grid graph, which has been used for 30 years in North America. With the display, there is it can also be the grid graph that is shown, but there is a concern about having the display available outside of the cab, which is a must in many states and provinces for the enforcement to be able to look at the information. There is also potential liability issues if the display falls in the process of handing it over to the enforcement. And there is also a concern about the possibility of manipulating data or making false apps on smartphones to show wrong or false information. And because doing apps on smartphones is fairly easy or very easy, and that could lead to problems of manipulation and loss of trust in those systems. Looking at the Canadian standard for ELD EOBR requirements, it was written in such a way that it has to be compatible with US requirements. It is focusing on manual inspection only, so it does not require or lay out a standard for electronic data transfer. And the same way as for the US, it does not require to have to transmit wirelessly the data to the office, which again is good since it will allow cost-effective systems for small carriers. It also requires, as the ELD rule in the US, that the systems must be connected to the vehicle. And yeah, that's the highlights for the Canadian requirements, or the draft requirements. So how the ELDs will look like in the future? There is today on the market many types of ELDs, and I would like to characterize them in three groups that we'll find once the ELD rule is out in the US, and if Canada also follows the same way. The first type of ELDs would actually be fleet management systems with an embedded ELD functionality in it. So it is systems that have many features, and one of the functionality of the fleet management systems will then be an ELD functionality. They rely on wireless connectivity because the main actually point for carriers to buy those systems today is to increase productivity, and that goes most of the time hand in hand with real-time availability of the information. For those systems, the roadside inspection can be done today and in the future through display, or optionally by connecting a printer to have a printout. The second main category of ELD would be one that takes advantage, or that uses smartphone or tablets, having a black box connected to the vehicle and then fixed in the vehicle. The tablet communicates with the black box in the vehicle through Bluetooth or Wi-Fi in some cases. And so this is the way for those systems to comply with the requirements that the ELD must be connected to the vehicle. In that case, the roadside inspection is done through the display directly on the smartphone, or it can also be receiving in the future, when the ELD rule is in place in the US, it could also be the receiving email or information on the internet from the enforcement. And I also didn't mention that that is true also for the previous slide. The information shown here on the tablet or the smartphone for manual inspection is going to be a challenge because of the possibility of doing fake apps, as I was mentioning before. And then a third big category of ELDs, and I expect that there will be many suppliers for each category of systems, would be to have a standalone system with a dedicated device that does electronic logs in a very cost-effective way then. And this standalone system will probably have an integrated printer for a reliable and fast manual inspection at roadside. So this is all of my presentation, and I'm happy to take questions.
Thanks for this nice presentation. My conclusion is that systems actually are not tamper-proof. There's still possibility to violate the code inside. And from my experience, because in Quebec, and I'm from the Ministry of Transportation in Quebec, and we've implemented, as you know, speed limiters, we were reading ECM. And we just realized recently that a lot of companies offer to manipulate the data into the ECM, change the data into this ECM. The result is that we were catching people on radar speeding at 115, and then we were checking their ECM with a protocol that give us, what's the speed limit, and it was indicating 105. So the technology is not tamper-proof, and what is a concern for me is that those systems will be connected on the ECM. ECM is quite easy to manipulate, and I'm just looking at this and says, are we ready to move now? I don't think so. There's a bunch of issues. There's a bunch of challenges that you've indicated, and I think they're accurate. Are we actually ready to move in North America, knowing that there's two standards, the Canadian and the American? The American standard is not ready that much. It's supposed to be published in the fall of 2015. It's tomorrow. And in Europe, they're well more equipped. What I know from Europe is that the enforcement officer have devices that they plug into the recorder. They can download up to 365 days back. And the chip card is issued by the Ministry of Transportation to make sure that the company is not trafficking chip cards of their drivers. So it implies that for the Ministry of Transportation in each province, each state will have to issue chip cards. Nobody talked about it before. Do we rely on the company to produce those chip cards? It would not be very prudent, I would say. There's a big opening for trafficking chip cards of their drivers. My conclusion is that, with your presentation, I don't think we're ready to move now. There's a lot of work to be done. We did not import the system from Europe, which is fairly good, I think, because they have a standard that thick, published by European Commission, and all the countries in the European Union are using the standards to harmonize the. At the time I went in Europe, there was two systems, Quatra and Siemens were producing devices that were authorized by European Union. There's probably more. As a manufacturer, my final question is, as a manufacturer of those devices, do you think we're ready to move on tomorrow morning?
So, there's many questions, but tamper resistance, and I was trying to use tamper resistance rather than tamper proof, because nothing is ever tamper proof. But the point, about the tamper resistant points that I had in the key success factor is defining a tamper resistance level in a scientific manner, so that enforcement authorities can identify, and also fleets can have the assurance that system brand A, B, X are compliant with the same tamper resistance level. And that, because tamper resistance, it's a choice between, it's going to be always a compromise between between cost and tamper resistance. You can have extremely highly tamper resistant level systems that are going to be very costly, and then the cost of the systems will not be acceptable for the purpose of the systems.
I understand this is a risk management, and then we are putting the level of risk at that level.
Right.
What I understand from your presentation is that this level of risk or this level of tamper proof is not set now. Has not been set so far.
It is today in the Canadian standard and in the proposal in the US, there is no scientific definition of the tamper resistance level to achieve. There is tamper resistance measures required, such as the system has to be connected to the vehicle, to the ECM. That's a tamper resistance level. Tamper resistance measure, there is the requirements that the system have to have geolocalization, so most typically GPS. That's another tamper resistance level. there is no uniform scientific definition of the temper-resistance level. That's a risk, definitely. Now, if you compare the European system to North America, it's the approaches in many ways are very different. So the approach in North America to actually have driver identification cards issued by authorities is extremely unlikely to happen in North America. So that shouldn't be if there might be other ways to do that if through the certification process the better actually a third-party certification process, if you can ensure that the identifications of the drivers issued by each ELD supplier are truly unique, then you can also achieve potentially a sufficient temper-resistance level when it comes to driver ID. That's an example.
Is this question has been raised so far?
It has been raised and discussed, yes, in many instances.
And as a result, do we have a conclusion to this, or are we sure? Is there a process for the vendors to provide chip cards that are not falsified? Or
no, because there is in the US ELD proposed rule, there is a requirement that the ID generated by the ELD systems be unique, but there is no definition of what that ID process is or should be.
Okay, so it's difficult for enforcement to trust this as long as they have to reach. They'll have to test the system to see if it's falsified or not.
So it goes back to having a certification process that is sufficiently efficient, and so that for enforcement to be able to trust and to know which systems are compliant or not.
Okay, thank you.
So
I appreciate the time tag teaming off of Benoit's comments here. I appreciate his expertise, but I'm wondering on the other side of that, how do you think that we should spend how much time finding out a true way to verify this data while we're currently using a paper system that has numerous ways to be falsified, more than an advanced creating a fake app or falsifying data of an engine? Do you think that we're spending too much time trying to define that now, or is the reputation in the future what we're trying to protect for ELDs?
I think that ELDs will be an improvement to temper resistance compared to paper logs. And I think that this process of defining the temper resistance and refining how ELD should be will be something recurring. And we've seen that happening in Europe, where the standards have evolved over the years. Tachographs have been mandated for over 40 years, and then the technology has changed. And the manipulation attempts have changed, and the regulation has kept up in a cycle of about 10 years, because at the beginning, everything was fully mechanical. So anyway, the regulations have to keep up with the evolution of technology, and that also includes the tamper resistance mechanisms in that case. So there will never be a perfect a point in time when there will be a perfect standard that makes impossible manipulation. That will never happen. So at some point in time, there needs to be a stake in the ground, and then go from there, which doesn't prevent it to improve the technology and the requirements down the road.
I have just 3 short questions. You made a reference to the countries in the world that had tachographs or ELDs, and that middle category was partial enforcement or partly enforced.
Mm-hmm.
I just wanted to be clear I understood you. Was that where tachographs were used for speed enforcement, not necessarily for hours of service? Or what exactly does that category mean?
There was also many countries in that category. So there can be, depending on the country, there can be different reasons for a partial enforcement. In some cases, it was that the regulation was passed, but actually never enforced. There was never laws or regulations also issued to apply penalties for violations. So there is no enforcement. It can be technical problems, lack of certification process that made it impossible for enforcement to actually know which device is compliant or not. That also happened in some countries, for example, China.
Okay.
So there is a mix of reasons for partly enforced, and we'd have to go into details in every country, which we can do if you have the time.
Okay. My second question is, you suggested, you were advocating that we might need a third-party accreditation process to deal with the tamper-resistant level of security.
Mm-hmm.
Were you suggesting that that third-party accreditation should be for to replace self-certification, or just to focus on the tamper-resistant side of it?
Well, the key
Because
thing
the
needed
US
for
is
certification is the tamper resistance.
No, but the U.S. is advocating self-certification.
Yes.
So you're advocating for some level of tamper resistance certification.
Mm-hmm.
Are you suggesting that that's just partial certification by a third party that only focuses on the tamper resistance side of it? Or were you talking about potentially a better approach would be to go third party accreditation for all of it?
My suggestion is for third-party certification for all the criteria that are important for success, which include tamper resistance,
Okay.
but also standardization of interfaces. Because if the download interface for enforcement does not work, then the system is useless. So it's not only tamper resistance, but also the key interfaces.
Okay, and I found your presentation very useful. I'm wondering if I could get a copy of it.
Sure,
Yep.
absolutely.
Okay, thank you.
I'll keep it shorter than Benoit's, which isn't hard. I guess mine are more comments than questions. We have a few carriers that we've run into over the years that are using these more so lately, and we have a couple of carriers that operate in Saskatchewan that they swore up and down there's no way they'd ever use these, especially if they were mandated. They voluntarily adopted them, and it's a fleet management tool.
Mm-hmm.
They're wondering why they didn't do it sooner. So in their experience, they've probably paid themselves back many times over in the short period of time that they use them because they have better control over their operators. I don't think from an on-road enforcement perspective, I talked to some of our officers that have dealt with the electronic systems. Their biggest concern wasn't that they were tamper-proof or there were tamper issues. Their issues were with the ability to actually get the data to a form that they could use it. We're in one of the jurisdictions where the officers can't enter the cab of the vehicle, so they have to be able to get the information outside the cab. And so for those systems where you're not able to feed it outside or take it outside the vehicle, they did indicate that either a wireless system where they can actually transmit it to their scale house or to their vehicle so they can visually view it on their tablets. So the three things that they really talked about was having some type of interface that they could use and having that data in a format so that they can actually view it, which kind of speaks to the standardization and some of the challenges they're running into with that. The other thing is if the format is convenient, they say it's about the same time as a logbook, paper log to review it. But if it comes in a format that, such as this one smartphone you saw, that they can't really view it very well, they said it probably adds 2 or 3 times the amount of time to try and review that on just the interface itself. So those are some of the items that, from their perspective, are important that are incorporated into any of the technologies that are coming forward. And I'm pretty sure the standard will probably speak to that when it's finished.
Right. And to that point of standardization, once you have a standard, reliable standard to download the data, then the market can also offer many systems to enforcement to best and most easily read the data. We also see that in Europe when there is a multiple options provided by suppliers also to enforcement on to read the data in a reliable manner.
You were talking about leveling the playing field. I understand that, you know, most companies who are already equipped with this are afraid that someone who is on paper log, falsify his log, is cheating the system and is cutting costs because of that. To your knowledge, is there any existing study that measure and quantify the difference of level playing field? In other terms, do we know exactly if there's a difference in level playing field, and how much money are we talking about? How much disadvantage are we talking about? You know, the industry can complain that there's no level playing field, but is there any data available to measure this at this point, to your knowledge?
I don't know of any study that quantifies that.
So we want, because it's strange a bit, we want to level the playing field, but we don't know exactly if the playing field is not leveled at this moment. It might be, but we cannot measure that. How severe is the problem?
I mean, there is some studies about how much manipulation of the logs there are, but they're also up to interpretation, and I don't think there is a complete consensus about the percentage of manipulation of the logs. But if you ask to carriers and drivers, it goes from 10 to 50%. So.
Okay, thank you.